Hi, I'm Ronnie Staten, and this is my presentation on rock types. There are three main types of rocks. The first one's igneous, there's sedimentary, and metamorphic. Igneous rocks can be a single mineral, or they can be an aggregate of many minerals, meaning that one rock contains a lot of different fragments or crystals that's all contained into one. Igneous rocks are created by volcanic activity, so in one way or another they came from a volcano. They could have been created at the bottom of the ocean on oceanic crust or above the ocean on Earth's crust. So it's continental crust. Those will be the lighter colored rocks, more felsic, and the ones formed underwater in the ocean, those are more mafic. Um, Igneous rocks are the oldest rocks on Earth. All the other rocks are derived from igneous rocks. A mineral is composed of one substance. It could be something such as calcium for calcite, gold. Those are all minerals, and a lot of times they're all one single element. Halite, such as it's the same as salt, it has a chemical formula of NaCl, and that's exactly the same for halite, regardless of the size of crystals. Coarse grained rocks is another way to classify igneous rocks. Um, if it's a coarse grained rock, it means it was formed intrusively, and that just means that it was formed inside the Earth's crust. Um, the longer it sits inside the Earth's crust, it cools slower than being extracted out onto the Earth's surface. So the longer it can sit there and cool, the more the crystals will collect together, and you end up with larger crystals. Examples of coarse grained igneous rocks are granite and gabbro. And later in the presentation, there will be a picture of granite. Fine grained rocks are formed at the Earth's surface. They can either be shot out of a volcano, and they can also be formed underwater, such as Hawaii, where the magma flows up, flows under the water, or flows quickly out onto the top. It cools really quickly, so there's no chance for the small crystals to form, so they'll be very small. As in the example from Hawaii, basalt has small crystals, and that's primarily the rocks that make up Hawaii. One other type of rock that has no crystals at all is obsidian, and that's also known as volcanic glass. It cooled so quick that no crystals at all formed. The next type are sedimentary rocks not formed from volcanic activity. These are rocks that are made up of igneous rocks and seashells. They're all just cemented together by fine particles of mud, clay, that type of stuff. Um, and they're compressed and packed on the bottom of oceans or down in sediment deposit areas. The grain size of sedimentary rocks can range from not being present at all to huge boulders. Could be the size of a car. Pieces that make up sedimentary rocks are called the sediments. And there's two primary types of sedimentary rocks. There's clastic and non-clastic. A clastic sedimentary rock is made up of rock fragments, shells, or other sedimentary uh, elements. When you look at the rock, you'll be able to see crystals in it. Those are grains of sand, or you'll be able to see the seashells. Even if you can't see them, such as sandstone, some can be really small. If you rub your hand over it, you can still feel the sediments or the different pieces in it. The examples are sandstone conglomerate, which is basically a lot of small pebbles or larger pieces all stuck together, and breccia it has really jagged edges that's cemented together. Non-clastic sedimentary rocks are made up of one chemical. These are things such as coal, gypsum, and limestone, and they can be composed of minerals that precipitate out of water. It's stuff that's dissolved in it. Once the water evaporates, it leaves behind the particles and they settle to the bottom and collect to make a single rock. The gypsum's an example of that, where all the pieces settle out to the bottom and there's nothing else in it other than the calcium that's in the gypsum. And as far as coal, that's made up of living plants or organisms. So in swampy, marshy areas, it was covered over with mud and dirt, and it actually prevented oxygen from getting to it. So the oxygen didn't break down the remains, and all the carbon stayed inside the plants. And over time, it turned to a solid rock. Metamorphic rocks are a little different than the other two in that they've been exposed to extreme heat and pressure. They're still based off of the other two. Metamorphic rock used to be either a sedimentary rock or an igneous rock. The actual crystals that's inside of the rocks do not melt during when they're changing to metamorphic rocks. It's the extreme heat and pressure that forces them to align in some cases. There's two types of metamorphic rocks. They're stratified or non-stratified. The stratified rocks are rocks that have visible bands or lines that circle around them. They look a lot like layering of a sedimentary rock, but you can't separate them. They're just lines of dark minerals that cross across the side. And it implies that there is extreme heat and pressure applied to two of the sides of the rock. So if you took a rock in your hand and you put your pointer finger on top and your thumb on the bottom and squeezed, that type of pressure on the top and the bottom would give you the stratified lines through the middle that would run parallel to your thumb and your pointer finger. The same as if you turned your hand the other way, the lines would run up and down, and depending on which side the pressure was applied. Examples of stratified rocks are gneiss and schist, and the picture of granite. That was what a gneiss rock was before it underwent extreme heat and pressure. So it still has the same makeup, same minerals. Just you can see that some of the other minerals have stratified out so that it has banding. For the schist, it's a little harder to tell that it has banding, but actually along the edges, it looks like flake layers, and you'd be able to see the crystal lines in the side of that. And that one came from shale, which was a sedimentary rock. Non-stratified rocks are rocks that don't have any rings or bands. There's still noticeable change from the parent rock, but it doesn't have the defined lines like the stratified rocks do. In the example below, marble is white, but you can still see some of the lines that are a little darker. They're not necessarily stratified lines, but they are lines of the other minerals that was within the rock when it was metamorphosed. And that concludes my video on rock types, and I appreciate you watching and have a wonderful day. Thanks.